Okay, everyone, welcome to this session, which is RDS improvements in Windows Server Next. My name is Derek Asoka, and I'm a Senior Program Manager on the Remote Desktop Services team. Let's see if this will work. Okay. So today's session will cover all the set of capabilities that we're adding in remote desktop services in Windows Server Next. The first thing we'll cover today is really covering the wide landscape of graphic capabilities that we've added on top of Hyper-V and from 2012 R2. We'll also cover additional workloads that are now supported in Hyper-V and in Windows Server VDI. And these are really thinking of workloads from knowledge worker to power user and designer or engineering type applications. We'll also look at additional GPU configuration options that we've added for the Remote Effects vGPU component that runs in Hyper-V, and really in response and tied to additional workloads that we now support. We'll also do some demos. There'll be a lot of demos in this session that will really focus on what the user experience will be in Server Next in VDI. And we'll also go over some additional RDS investments, not necessarily through demos, but I'll cover some new things that we're adding that I'm sure you guys will be excited about in Server Next. Okay. So we're a big team, and we've grown over the past couple of years. The main thing we know is the remote desktop protocol that I'm sure we're all familiar with. We've now added a set of clients. Essentially, if it has an app store, we're on it, and also Windows. There's a set of multiple clients we actually ship on Windows today, and some additional ones that will be coming shortly. There are also the VDI components that we're all familiar with. If you run any type of VDI on top of Hyper-V and you use our broker or gateway, or our protocol, those are available as well. And we also ship the RDSH, formerly known as Terminal Services, and our new finished service on Azure is Azure Remote App, which allows you to stream applications hosted and managed by Microsoft in the Azure cloud. Okay. To kick us off, I'll start with GPU virtualization, which is an area that we've really invested in this version of Windows that's coming up. And a really good place to start is to look at the landscape of solutions that are available today. There's several. They're very confusing. They're marketed the same. But my goal, at least in this slide, is to give you what's available in the market, compared with what Microsoft is offering, and allow you to understand the different types of capabilities that each solution has. The most basic one is what's called WARP, or software type, or an emulated CPU graphics device. And you get that for free on Hyper-V if you fire up a VM, and the type of graphics you get from a basic display adapter is that. It's CPU accelerated. You don't get anything fancy. You may get some levels of DirectX, but nothing is really guaranteed depending on how an application wants to use graphics. NVIDIA has a solution that technically is device assignment. And here what you do get is a one-to-one mapping for an NVIDIA GPU to a virtual machine. So that means when you spin up that VM, it completely and totally owns that GPU. It's not shareable, and you have an NVIDIA driver running in your VM, which uses an NVIDIA driver running on the host. And that's how it works. But it's a one-to-one mapping. NVIDIA has another solution by which they've actually virtualized the GPU itself with hypervisor integrations, not on Hyper-V, but you get that on Zen, for instance. And they can partition the GPU, or they give you management capabilities to partition that GPU. You can splice it whichever way you want, if it's through memory or number of VMs that you want running on it. But essentially, those VMs get to share that GPU up to whatever NVIDIA allows today. Okay? So those two solutions in the middle are really married to NVIDIA capabilities. Okay? The last one that we'll really focus on today is what's called power virtualization, and that's what we have at Microsoft on top of Hyper-V. We ship a GPU software, a GPU or synthetic driver that we have running in the VM that talks to a physical GPU through Hyper-V. That GPU, as you can see from this diagram, could be any GPU. Today I'll be running a demo in this box, which is essentially an Intel integrated GPU. We support that. Or it could be any type of GPU that is supported in a server class production deployment. So that could be AMD, NVIDIA, or even an Intel integrated device. Okay? And in this case, all the VMs, of course, have the synthetic remote effects vGPU device on it. They get to share that GPU, and essentially it's the capabilities of your host machine, or your server machine, and that GPU that determine how many VMs you can scale on it. So each of these capabilities, as I mentioned, has different attributes, and I really won't go through each one of these, but this is a really good slide for you to have a good idea of what you get. Each solution is optimized for something, whether it's performance, whether it's scale, whether it's the type of workload that you want to run. So if you have a user who's running Microsoft Excel day to day, you don't want to give them a GPU. They're expensive. If you want scale for a set of users who need graphics, the remote effects GPU virtualization device is a good solution. If you're running workloads, let's say, that need heavy NVIDIA-specific compute, for instance, you can go with the device assignment solution. But as you can see, when it comes to cost or scalability, or whether you want to have hardware options open to you, it all depends on how you want to slice and dice this. Today, we'll be focusing on really the one to the right, but in Hyper-V, you do get these two solutions today for free. Okay? So as a quick recap, if you do go with the software solution, what's called Warp, on top of Windows, CPU emulated, you do get some limitations, but you do get all the capabilities such as Aero or transparency. If you're using Microsoft Excel, for instance, you get some of the rendering effects that you have there, or PowerPoint. If you do go with Remote Effects vGPU, you do get a fully hardware-accelerated VDI environment. You get full DX, OpenGL, OpenCL, and we'll talk more about those in the upcoming slides. And it really is the best solution for 3D graphics performance in Hyper-V today. So the unique benefits of remote effects, everything is built into Windows. We'll kind of go over some of the management and deployment scenarios, but everything is essentially available through Hyper-V, either through the GUI or PowerShell. You do get, of course, for free all the GPU placement algorithms that we have. We have a round-robin way in which we provision GPUs as they spin up. If there's no more allocation available on that VM, we do provide capabilities for that as well. And you also get performance counters, which can allow you to really dig in and see host side what type of capabilities are essentially what you get on the host for performance, and also what you're serving up to the clients. We have counters for those. Another really good thing is you have no vendor lock-in. So if your budget allows, you can spend up to $10,000, $12,000 in GPUs. If not, you can go with cheaper and also capable solutions. So from Intel integrated devices, if that's a solution you want, or you could go with AMD or NVIDIA, whatever really is your choice based on budget. But you don't have to be locked into a specific vendor or solution in this case. And also, it's a scaled GPU virtualization solution. Some of the testing that we've seen, we can scale up to 100 VMs, depending on the workloads that you need. For Server Next, we're still working on optimizing for scale and performance at the moment, so we don't have any specific numbers to share. However, when we do ship, we'll have very specific numbers to share for scale and what we see for all types of workloads, from knowledge worker all the way to engineering and power user workloads. Okay? And now we have no limitations on the workloads you can run. So if you have users that just need DX type applications, you can get those. And now we're scaling up, and if you have users who want to use engineering type applications as well, and the APIs that those applications need, we have support for those as well. Okay. The system requirements and Server Next are very simple. Essentially, if you can run Hyper-V on that machine, you can run remote effects. We try to match the requirements for remote effects as closely as possible to what Hyper-V needs. On the GPU side, really, if you're going into a production type of deployment, you'd be looking for a workstation, a server-class graphics card. Most of them today are DX11 and above, OpenGL Photo and above, and they mostly will also be writing to a newer driver model. So at the moment, NVIDIA, AMD, Intel are all testing 2.0 WDDM drivers. So anything that supports 1.2 and above, you get. And those are examples of GPUs that we support today. So it's very simple to configure and manage. If you've ever installed a role or a feature on Windows Server, Hyper-V, essentially you install the RDVH role. After that, make sure you have the latest GPU drivers. We get a lot of support calls where someone says, well, it's just supposed to work, but no driver installed. Nothing can run natively or in a virtual environment. So it's good to call that out. Through the Hyper-V or through PowerShell, if you want to automate this, you can select which GPU you want to run. So you can actually choose, let's say, one adapter gets graphics, the other adapter doesn't, and is used, let's say, on the console, in a console session. And you get load balancing as well. And after that, you can essentially, from the VM, configure it to get the remote effects device. We have UI for that in PowerShell as well. And, of course, power on your VM. And that'll give you remote effects. So we'll quickly dive into a demo, and I'll show you that process. All right. So this is a server next host. It's running off this small box that I have here. And as you can see, what we'll do if you want to install the RDVH role, it's very simple. We won't go through it now. It takes about 5 minutes to reboot the server and add the role. So we've added this role here. Essentially, if you come here, you select Remote Desktop Services, and check the virtualization host. It says installed. When you check that, it pops up a UI telling you Hyper-V and some additional features. You say yes to that. Check the box to restart your server once the installation's done. It'll automate all that for you. When the server comes up, the RDVH role is installed. You have Hyper-V running, and you're ready to use remote effects. So if you suspend the belief for a while, assume we've gone through the process. This server is rebooted. It's up. I have Hyper-V running here, as you can see. If I right-click on the Hyper-V settings, I can go, as you can see here, it automatically detects the Intel integrated GPU that's available for use with remote effects. Okay? So we do some type of filtering. For instance, if you haven't installed your driver, we'll blank this out. We'll show there's a GPU available, but there's nothing to be allocated because we need that native driver installed. Okay? So in this case, I have the drivers from my Intel GPU, and I've checked this box to say use this GPU with remote effects. Now, there are some GPUs that have multiple adapters in them, and you'll see those listed individually in this UI, and you have the choice to use whichever adapter you see fit. So you don't have to essentially allocate the entire GPU or all the adapters in that GPU to be used with remote effects. Okay? And that's essentially it. So this host is ready for use with remote effects. I have two VMs here. This VM's already configured, but it doesn't have the remote effects 3D video adapter. What I'll do is I'll start this VM just to show essentially what the experience is without the remote effects adapter. We'll run an application, and you'll see what the experience is. And essentially, that's what applications query when they need graphics capabilities. So we'll just spin this up. It's already booted. Oops. So in this case, Haven is this is a graphics benchmark. It can run in either DirectX, DirectX 9, or OpenGL mode. In this case, we'll try OpenGL because we know that's something we want to test in this VM. And if I say run, of course, the application will try to create an OpenGL context in the video memory. It doesn't see that. It can't go ahead. It crashes. And so I'll hit cancel. It elegantly tells me I need graphics. So I'll shut down this VM. And we can go into settings. And in add hardware, I'll select the RemoteFX 3D video adapter. When I add that, I get a set of options. And for configuration capabilities that we added in Server Next, you get a few. One is we've added the number of the resolutions we support now up to 4K. So if this is a user who needs a 4K resolution for this VM, they get that. I'll take questions after if that's okay. Previously, we had a limitation up to 2560 and 1600. The second thing we've done is we now have allocation, root partition for graphics for this VM. So previously, we had a limitation where you had to know this really crazy configuration where if I give this VM 2 monitors and this resolution, then I get this amount of video memory. Well, now you can actually just go here, and regardless of the number of monitors or the resolution you're using, you can allocate dedicated video memory for this VM. And so that doesn't come from the GPU. That comes from the root partition memory on this Hyper-V host. Okay? So in this case, we'll do this. I'll hit apply. We'll say OK, and we'll spin up this VM and see if we can run that application. Okay? So it's up and running. Oops. So it's up. I can now launch Heaven, still in OpenGL mode. I can hit run, and we'll see the application running. Okay. So that's a quick demo just to show the configuration capabilities to turn on RemoteFX on a Hyper-V host and some of the configuration options that we've added for a VM in Hyper-V. Okay. So it'll take a minute to load. It's pretty heavy benchmark on a not so capable GPU. Okay. All right. Okay. So we'll run this benchmark for another demo, and the demo will be on a real production environment, all the way in Mountain View, which is where we're located in our labs, and we'll see what the performance is. Okay, so this time I'll switch back to the presentation, which is here. Okay. So what's new for graphics? After we shipped 2012 R2, we talked to a set of customers who were very vocal. They gave us some feedback. And some of the key things that the feedback really revolved around was things like application compatibility. We had users essentially tell us that, well, we love Hyper-V. We love the fact that we get all these capabilities with RemoteFX. However, there are things around performance and app compat, even with DX, that are an issue for us, really adopting the platform. Okay? The second thing that we heard was, there's this end-to-end experience that users expect. When they go into a virtual environment, they really don't want to know that I'm now running in a VM, and I have to consider that I'll be, let's say, getting 75% of the performance that I have from a native experience. The last thing was everyone said essentially if I'm going VDI, if I'm taking my users into a VDI environment, I just want to be able to run everything, not piecemeal. I don't want to run one application native, one application virtual, and have this really complicated management for applications. So allow me to run all my applications in a VDI environment. Okay? So after acquisition, we've essentially gone through a set of different releases. We started from a simple DX9 on top of Hyper-V. We've gone and added DX11, some GPU management. Server 2012, we added higher video memory up to 1 gigabyte, essentially DX11 support. Made sure that our driver was HCK compliant. In Server Next, we really stretched ourselves, and we have around six or seven new things we've added. The first thing is we now support OpenGL and OpenCL APIs. So that means if your application has all these graphics and compute requirements, we have support for those. And these are all written from the ground up. It's about 2,000 APIs, so it took us a while to actually polish them up. As I showed you during the VM configuration setup, we now support up to 1 gigabyte of dedicated memory for a total of 2 gigabytes of video memory. Okay? 4K resolution support, single monitor at the moment, but that really is to support the proliferation of new resolutions that users are seeing out there. We've also added support for server VM, and that means if you can actually run a server VM in VDI and get the full capabilities for graphics. This was something that a lot of hosters and hosted service providers told us. We can't run client VMs when we're running hosted services. In this case, we said, all right, we'll support server VM in full VDI, and you get full graphics. Okay? And that also comes with additional shell support for the desktop experience. And just really also aligning our strategy with Hyper-V, we also now support Gen 2 VMs. So if that's a scenario that you're adopting, you get that as well. And all these come with the full graphics capabilities on Hyper-V. You also get improved performance, and this really goes bottoms up from the VM transport, Hyper-V to VM communication, DX11, and also going forward in OpenGL. Okay. So the improvements really enable a scenario which really essentially looked at things from one perspective: is can we get engineering and designer workload supported on Hyper-V? Right. So for OpenGL support, we go up to 4.4. They essentially rev OpenGL almost every 6 months. So the current version, I believe, is 4.5. We support up to 4.4. We may go up to 4.5, but we don't know if that'll be within the Server Next timeframe. OpenGL API support, most applications are really congregated around OpenCL 1.1, and that's where we've essentially capped support for now. 1.2 is the current shipping API level. As I mentioned, you get 1 gigabyte dedicated VRAM. It's decoupled from resolutions and amount of system memory that you've allocated that VM or the number of monitors that you have. Some applications that we test with are Photoshop, Esri's ArcGIS Pro, and LS Prepost, if you're familiar with those. We also have a dynamically improved end-to-end experience. Jitter is one thing from a rendering perspective that we really made sure that essentially we can render at 60 frames per second if an application needs that, 30 frames per second, but really improve how many frames we drop, and end-to-end in our graphics pipeline also make sure that when we hand over frames for encode and decode, all that stuff is essentially, we don't lose like 10 frames every time we go through the entire protocol. Okay? And we've made significant improvements in our app compat, either through learning a lot what these graphics applications do or working with specific vendors to make sure we have the right support, or we get our graphics driver whitelisted for some key applications. Okay. So some details on OpenGL and OpenCL. We've talked to some customers, and we hear the common questions come around, so I thought I'd cover this. First of all, it's essentially just enabled in VDI. And so if you're remoting using RDP to a physical machine, you don't use the remote effects vGPU driver. You're essentially remoting to a physical machine that may have an NVIDIA, Intel, or whichever GPU you have there. Those two are not related, so you don't get OpenGL in just a machine-to-machine remoting scenario. And server-next VMs get the full remote effects graphics support as well. So all the capabilities that are available in Windows 10 are available in Windows Server Next. Okay. As we saw, you just don't get it for free when you run a VM in VDI. You need to enable the remote effects vGPU component for that specific VM to get the driver support and get OpenGL or OpenCL capabilities. Okay? If not, you just get OpenGL 1.1, which is what Microsoft has had in Windows for a very long time, but that also has its limitations. Okay? Supported configuration, from a guest perspective, Windows 10 Enterprise, that doesn't change, or Server Next Standard, and you host Server Next for all the capabilities that we're discussing here today. Okay. For conformance testing, really to make sure that we have the right level of API support, it's stable, it's supported. We do use the industry Kronos suite, so we pay for that, and we go through their API test suites. We also use Piglet, which it's an open source suite used by essentially any graphics vendor out there. And for performance, we use SpecViewPerf. And these SpecViewPerf especially is a tool that once we get closer to releasing, we'll have numbers on how we perform, native as opposed to virtual. Right now, we're seeing very, very good results, almost above 75%, 80% for some of the tests. So it's almost as good as native. And then we're also doing targeted testing with specific vendors for specific classes of applications. Okay. So for now, we'll jump into a demo. I'll just exit that. And the first demo, I'll connect to a client VM. And hopefully I'm still connected through VPN. I am. And so, as I said, this is a real demo. It's not running from this box. This is a machine all the way in Mountain View, in our lab, just to show you what the real experience is. I have this tool here that'll show us what our bandwidth is. And as you can see, the round trip time is about 76 milliseconds. And that will be reflected on what we'll see in the real RDP protocol performance. So essentially, that's our latency there. Okay. So the first application I'll show here is, once again, we'll launch Heaven. And I'll just move this out. So the GPU that this VM is running on is an NVIDIA Grid K520 card. So pretty powerful grid card. And the numbers that we really care about in this case, as you can see, just based on the latency here, are the frame rates that you get here. All right. So essentially, we're rendering almost, depending on the scene, you could go from 20 frames per second to 70, 60 frames per second. And the jitter that you're seeing here isn't really a rendering issue. It really is RDP, just based on the 76 milliseconds. Okay. But to show you what we can do here is go to camera, and I could go free. This is a tough scene, and you can see essentially see what the rendering is like, or how smooth it is as I pan around. Okay. If I go back to cinematic, you can essentially see what it's like. All right. So as you can see, it's running. You get full hardware acceleration running in a VM. I'll quit this, and I'll say OK. That'll exit. That was DX mode. We'll do an OpenGL mode just to show you how it also looks like in OpenGL mode. It should be similar to DX. And we've made a lot of progress in our DX11 implementation. So at the moment, what we're noticing as we finesse our OpenGL performances, you could get, let's say, the average frames per second if I was to run through this benchmark would be, let's say, 32 on DX. On OpenGL, we're still kind of working the kinks out, and the performance is in the mid-20s. However, still, if I was to go into camera mode and do free, you can still see the rendering is almost crisp, no artifacts, no issues in the rendering at all. Okay? All right. So that's our first demo. This is a good benchmark. If you have access to the latest version of Server Next when it comes out, it's a benchmark you can download, play around with, see what type of performance you get in your environment. Okay. The next application I'll test here is Photoshop, and what I'll do is I'll just launch it. Let's minimize this. Now, if I didn't have remote effects enabled on this VM, two things would happen. When I launch Photoshop, it'll say, "Hey, looks like you don't have a graphics adapter. I'm sorry. I'll work, but everything you'll get will be CPU bound." And on top of that, there's some capabilities you won't get that I need for a GPU. So if they're compute type capabilities that Photoshop needs, you don't get those, or if there are any rendering capabilities it needs. But in this case, we have the graphics capabilities enabled and detected by the application. If I hit an advanced settings, you'll actually see it detects OpenCL, and it can use the GPU to do graphics. Okay, and we've been working very closely with Adobe. This is trial, and they've given us some scripts that we can use, and I'll just quickly show you what that looks like. If I run this as administrator, I'll say yes. And so these are not Microsoft-generated tests. These are tests that Adobe gave us when we told them, hey, we're working on a GPU or OpenGL performance capabilities. Can you share with us any tests that you run in-house when you test for your own applications, cross-platform, or in virtual environments? And this is what they gave us. So it's going through CPU and GPU features in Photoshop, launching things like blur gallery, adaptive wide angle, which are all OpenCL and OpenGL capable features that we now support. Okay, and this is a test that we use, and we see it runs natively and what numbers we get, and how it runs virtually and what numbers we get. But as you can see, it's running smooth. It's using all the capabilities that are available in Photoshop for what they test. All right. I'm going to close this and go back to the presentation. So hopefully that gave you a good idea from a graphics perspective what's coming in Server Next. Graphics is a very key thing in VDI and something that Microsoft is very invested in going forward. And we think while we do have the capabilities that we have today, we're always looking to innovate. And so I think this is a space that you should pay close attention to for what will be coming even post Server Next, and especially with the cadence of how fast we can iterate in Windows. The next thing we'll talk about is codecs. Most of you are familiar with RDP. The current shipping versions of RDP have a proprietary implementation of different codecs that we use. Those codec investments have essentially given us some latitude. We can do some things because they're proprietary. But when it comes to scaling for the world that is essentially out there for mobile devices that have capabilities that you have to standardize, what we are noticing is that going with a standard is probably the best thing to do. So what we did in Windows Next is invest in the H.264 or the AVC codec. So that means now if you have a device that essentially has hardware that supports offload for decode, or on the server side, encode offload, that's something that we've standardized and you can now take advantage of. And the reason why we did this is because what we are seeing is higher resolution support. With our proprietary codecs, it's an issue to actually try and support all that data that higher resolutions require. And with 4K and Ultra HD resolutions coming out, it was the best decision to standardize on a codec that essentially is built for these higher resolutions. Okay. And as I mentioned prior, AVC or H.264 is shipping essentially any type of device out there, whether you have an iPhone, Android device, a tablet, or even essentially a Surface Pro. It comes with the ability to offload decode. So with that capability, we thought that it makes sense to just use that. And the benefits is that it reduces the amount of demand that we'd have on the CPU, and that has the compounding benefit of reducing latency and reducing the amount of CPU we use, which essentially means clients can receive frames as fast as they can consume them. Okay. And then the standard itself provides better quality control. So depending on the QP ratio that we want to use, we can essentially bump it up dynamically and still provide a good end-user experience. So there are different QP ranges that H.264 provides, and we can move that up and down depending on what bandwidth you have or what your device is capable of. So a lot of flexibility to do rate control and quality control just built into the standard. So that's not something that we had to essentially start innovating on internally at Microsoft. Okay. However, there are some challenges with the off-the-shelf standard. So H.264, as designed, is great for video. If there's a video flying by, it's fantastic. But if you really are using an application, text is an issue. And it's really not built for giving you really crisp text. So as a result, you don't get that great text. And a good example is this. You can see that 420, which is off-the-shelf standard, that's what your text would look like if you zoom in to this example. And the right is 444. You can see how crisp that text is. The pixels. So essentially, there's no chroma. There's a lot of chroma that the standard just kind of drops for things like text. Because at that speed that a video is passing by, it's very hard for the eye to detect. So we've had to add essentially a lot of work to make sure that with the off-the-shelf standard, we could essentially get into 444 mode that adds all this chroma that is really good in case you want to do something like work on Word, or you care for a scenario which we really were focused on for engineering applications. If someone's working on a model, pixels are lost, you don't get that clarity, that's an issue. Okay? And also, it really doesn't give you the ability to do progressive updates, at least the way we want. So if we detect you're in a low bandwidth situation, we can give you different qualities or different different ranges as we gradually get to 100% for what the codec can provide. Okay. So a lot of work was done. Take off the shelf, make it available in 444 mode to really make sure that if you're using this, you get the best quality for text, you get really crisp rendering. And the one thing that we also made sure that we don't add as a constraint is if your hardware supports 420, you don't need anything to support our 444 mode. So any standard hardware out there can support it. At the moment, it's limited to Remote Effects vGPU. This is good to note. So it's not democratized for essentially basic RDP. We hope to get there. So if you're running in a graphics type of environment in VDI with the Microsoft Remote Effects vGPU, you get this for free. Second thing is if you're remoting from a Windows 10 machine and you have hardware capable to do decode, you get that for free. Okay, so those are the two key things here. So basically, what I'm trying to say is if you have a Windows 8 machine and you update to RDP 10, you won't be able to get this capability. You have to be on Windows 10. Okay. And now I'll do a demo of RDP. What I'll actually start with is a set of videos, and this is RDP 8.1. So what you're seeing here is on the right is Internet Explorer. It's running FishGL, which you can get for free, and this is another good demo that we made sure we can record. It's in the presentation as a video, so you can see this. But if you're testing it yourself, this is very good to at least see the capabilities that are available. And I'll play this, but before I play it, here, what you can see here is perfmon running in the host that essentially shows the frames per second that you get being served up to RDP to the client. And what you get here as well, that's very important to note down here, is the CPU utilization on the client side. Okay? So I'll play this video. And what you'll see, it's running RDP version 9600. And that'll give you a good idea of what frames per second we're seeing on the client side as I spin around on FishGL. And you can look at the CPU utilization. It's around 20%, 15%, depending on what's happening on the client side. And the frames per second we're seeing there are roughly 10, 15 frames per second. Okay? So very good example to show what exists today and what you get with RDP 8.1. Okay. All right. So let's go to the next slide. Next slide is RDP 10. Same scenario. We have server-side perfmon running to show you the frames per second, and here we have resmon to show you essentially what CPU utilization you're getting here, and the same demo FishGL. So we'll play this as well. And that's just to show you that it's a variant of RDP 10, an older version. I think with the previews, you'll of course get a later build with the newer version of RDP. But now spinning, you can actually see our frames per second have gone a little bit over 20 frames per second, and you are getting almost a quarter of the CPU utilization client side, right? So that's phenomenal to actually show what the codec is doing in terms of offload and taking the burden off the CPU. And in this case, if you're using a laptop, you're using a tablet, you really don't have to bear the power consumption that heavy CPU utilization will require. Okay. And I'll hit escape. And I we'll do a live demo. What we'll do here is let's do the same thing. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So I'll connect to my host, and I have this VM that's running on my host. Okay. My host is here running. What I'll do is, it's back here. This is my client machine. I'll go through an OpenGL demo. This is another demo suite that's available publicly. It's called Mad Shaders, but essentially generates a bunch of frames that allow us to see what activity is going on in the host. So it'll go through that on my host. What we'll see here is perfmon. It's running. I'll start running it, and these are perf counters. Essentially, three counters I'm using here. The first one is input frames per second into the pipeline, our graphics pipeline. The second one is output frames per second, and the last one is a counter called wait for client. Wait for client essentially says, how fast can I send frames to the client? If the client is slow, CPU bound, that wait will be high. The output frames are essentially what we are outputting out from the server to go through RDP to the client. The input frames are essentially what we receive from the GPU, take that up, run it through our encoder to encode it H.264, and then hand it off to RDP. Okay? So essentially what you want to see here is our wait times on the client are not that high, and our input frames, our frames going into the pipeline into encoding, and the frames coming out after being encoded are very close. Okay? So that means if we're rendering at 30 frames per second, those 30 frames per second are going into encoding, and you see 29 frames per second coming out. That means we're losing one frame, and we don't have to wait that long on the client. Okay? So so we can see both things happening. You can see in the background, it's going through a set of demos, and here it's looping through, and here you can essentially see how low the wait is. So essentially, not that low. And the input and output frames per second are so close, you can barely see them. But if I highlight, let's say, output, if I do that, you'll see where it is. If I highlight input, you'll see where it is. But the key thing here is with RDP 10, you can almost see that it is very low. It's roughly 0 to 10, between 0 to 10 milliseconds. Okay? So what I'll do now is I'll switch to RDP 8.1, what's shipping today. What we'd be looking to see is this blue line, does it go really high, or does it stay as low as it is here? And the spikes, as you can see there, really are either the demo switching, there's nothing happening, so there are no frames to send, and we'll think we have to wait. But typically, as you can see, when rendering is happening, the wait is very low. Right? Make sense? Okay. So I'll pause this now. And because I have to connect with the previous version of RDP, I'll have to essentially close all the RDP 10 sessions and then start with RDP 8. All right? So I'm going to close that. I will also stop running this demo so we can start. Say yes. Okay. And I'll exit. And just to prove I'm not cheating, this is build 9600, which was essentially the version of RDP that shipped with Windows 8.1. I'll also make sure that there is no RDP process essentially running here. Okay, there's none. I'll connect to my host. Which shows up here. And I'll also connect to my client machine. Okay. And as you can see from the host, if I go into About, this is RDP, the previous version of RDP. Okay. So once again, oops. Let me see what happened there. Okay. So I'll come here. I'll run the same demo loop. That'll be running. It's in the background. You can almost see the difference in quality, just the bleeding and that you can see in graphics. And now we can come back to perfmon, and I can run this, and we'll see the difference. As you can see here previously, what the weight was, and we'll see how the weight goes up immediately. So essentially what it's telling us here, if you're looking at this on the server side, is that with RDP 8.1, I can't process frames as fast as I can. It's taking up a lot of CPU on the client side, and that means that from a server side, I just can't send frames as fast as I did. With RDP 10, we're doing hardware offload, so that means the CPU doesn't have to work that hard. The hardware is doing all the decoding on the client side, and that allows us to send frames as fast as that client can actually receive them. And this is a key difference, because what you see here is that there's a big difference in the frames that we can actually send, and the big difference here is the frame rate has actually gone down with RDP. With RDP 8, we can't send that many frames, so we have to drop frames to keep up with what the client can do. And the client essentially is being tasked really hard to keep up with the amount and the quality of the frames that are being sent. All right. So the two demos here, one that you have in the presentation, is really instrumental in showing the differences between the two RDP protocols. All right. And we have tons of counters, so if you want to geek out on them, everything's available for you in Hyper-V. All right. I'll go back to the presentation. So additional RDS improvements, just to make sure that we cover some things we haven't really highlighted. As we said prior, you now can use a server VM in Hyper-V. It's supported with full graphics. What we've also done is made sure that that's fully supported through everything, the broker, the gateway, and through Server Manager. So you can create a template for a server VM. You can deploy it using Server Manager. You can get to it through the broker, right? And the same thing applies to Gen 2. Previously, we actually detected what generation, whether it's what type of SKU, and blocked. Today, or at least coming in Server Next, those limitations are lifted. So if you're a hoster or if you just want to give a server VM to a user, those capabilities are available. So fully supported through the RDS stack. As we saw, some of these VMs were actually server VMs. You wouldn't notice because I actually added the desktop experience pack, the shell. So it actually looks like a Windows 10 VM. Some additional changes are coming in the shell to make it actually really look like a Windows 10 VM. You get the new control panel. You can hide some UI from users. But those are, by the time we ship, those will be available. And those are also available as roles. So if you go to Server Manager and say, add a new feature for this VM, you can essentially say add a GUI shell, add the desktop experience pack, and that gives you everything. So it's also automatable through PowerShell. The gateway gets WebSockets that helps in load balancing. And if you have users who care about using RDP with pen remoting, that's also available as well. Okay. One thing that we're also providing that really doesn't accrue to VDI is client Hyper-V and the developer scenario. So I'm sure all of you have seen the HoloLens demos. So from a developer perspective, we've enabled developers in Visual Studio to get full graphics using RemoteFX vGPU. So that means if you're writing an application to work on HoloLens or Windows Phone, and you're using Visual Studio, you're essentially using the RemoteFX capabilities. And that's really a testament to the quality and the stability of the implementation in Windows. However, it's not a general purpose solution for now. It's only available through the Visual Studio emulators. So you just can't take your Windows 10 machine, turn on Hyper-V, and start running games and VMs. At the moment, that's not something that's enabled. Okay. So what's next for us? We think we can still improve on some of the graphics capabilities that I've shown. It's an ongoing work, as you know, even for NVIDIA, AMD, or Intel. Driver updates, there are always new things out there. So we still have things we think and believe we can optimize that are valuable to users and, of course, to you guys if you're taking dependencies on RemoteFX. And RDP10 as well, keep improving that performance, especially making sure that we can really, really reduce the bandwidth as well as CPU utilization. There's some small things like fine-tuning app compat issues, which we still think working with a lot of vendors who are very interested in these capabilities and onboarding them and making sure that we do have them signed up to say my application is supported in a Microsoft VDI environment, whether it's Adobe or Esri or Schlumberger, whatever type of big vendors that are out there. And I'm sure, as you know, because the 444 mode is just limited to vGPU sessions, I would like to extend it to every RDP or RDS scenario. So whether you're using a session host, whether you're just RDPing to a machine, if we can give you 444, that's something we want to extend and make sure users can get. And then, as I mentioned, more shell changes for server VM as a VDI guest. Essentially make sure if, as a customer, if you're a hoster, and this is something you want to provide to enable a new business capability, a scenario for yourself, you'll have that capability available. Okay? So I've done a lot of talking, mostly around graphics, so I hope you guys have a really good idea of what's coming next in Hyper-V VDI with RemoteFX, the RDS solutions. You have a good idea of the competitive landscape, and you know essentially what solution gives you what and how Microsoft sits. You know all the workloads supported. We've shown OpenGL, we've shown OpenCL, we've shown improvements to DX, we've shown RDP10 and the AVC improvements. You've seen configuration options for virtual machines and Hyper-V. You can go up to 4K resolutions. And then you've also seen what the user experience looks like, low CPU utilization, new standard codec. And then you also know what's coming next. So I hope this was helpful and useful for you. If you get a chance, please evaluate. Give us any product feedback as well in those evaluations. We read those very closely. And thank you for coming.